Hello everyone, welcome to Gate Academy guys. How are you guys? Just tell me, am I audible or not? Am I visible or not? Just let me know. I hope I'm visible. I hope I'm audible. Just tell me guys, whosoever are there, just let me know so that we can start over here now. Okay. So today we'll be solving a number of numericals, a number of previous year questions I'll be solving. Okay. So I have that and I'll be solving a number of problems over here. Okay. So I hope this is clear. The audio is clear. The video is clear. So let's move on. Okay, and let's start with the problems. Okay, so we have learned a lot many things in our previous sessions. We have learned a number of expressions. What are the equivalent expressions? We have learned the laws as well. Okay, we have learned what is implication. Okay, what exactly is tautology, what is satisfiability. We have covered all of that. So now I'll be solving questions based on those. Okay, so one is very basic yes, basic expression I'm going to take over here. Okay, and you need to tell me, let me write the question over here. Okay, let me write the question. The question says, I stay only if you go. I stay only if you go. So this is the statement given, this is the assertion given to me. I stay only if you go. This is the assertion given to me, and it is being told what is its converse. What is the converse of this one? What is the converse of this one? We need to find. We need to find the converse of this particular statement, assertion over here. So I hope we have already done the implications, number of English translations. Okay, what can be there in English, so that we can get to know that what exactly is it. Okay, because many times we had number of sentences and all of them were implying what, that it's an implication. If you remember, q unless not p, p only if q, q only if p, whatever such kind of thing, only q is p, something like this. We had a number of thing over there. Yes or no? So if you remember, so from that only we had this converse question, and it was asked by IIT Delhi in 1998. This is the question being asked by IIT Delhi in 1998. Okay, so I need to find the converse of this particular statement. So I know what exactly is it. I stay only if you go. So what exactly is it? I stay only if you go. Yes, I stay only if you go. So this is, if you remember, this part is going to be your P and this part is going to be your Q. This part is going to be a Q. That means P implies Q is there. P implies Q is there. And for the converse of any implication, what does it mean? The converse of this implication is going to be Q implies P. Q implies P. So what shall I write? What shall I write over here for that, for this part? I shall write something like this. Something like this. If you go, then I stay. Then I stay. Or something like this. I stay if you go. If you go. One and the same thing. These are exactly same sentences. Yes or no? Just think about this in your mind. Whosoever are watching, just think about this, whether they are same or not. Divya Jyoti, are you there? Just let me know. Okay, so these two are exactly same. So if you match, let me just tell what exactly were the sentences in the option. I stay if you go. That was the first option I was having, and that's the correct option. The others were, if I stay then you go, if you do not go then I do not stay, if I do not stay then you go. So from these we can directly say, like over here we had this, I have written the equivalent expression. Two statements I have written, both are equivalent. So this was the answer. Okay, this must be clear. This must be clear. And keep liking and keep sharing as well. If you are loving this session, if you are getting these sessions, getting the knowledge from these, if you are able to get the knowledge which you are not able to get earlier, okay, just because you are not able to understand so many concepts. Okay, so let's move further. Let's solve another problem. Let's talk about a question being asked by IIT Kanpur. Let's talk about a question being asked by IIT Kanpur. So this was asked by IIT Kanpur in 2001. Okay, this is the problem I'm going to take. It was asked by IIT Kanpur because this year, basically GATE 2023 will be conducted by IIT Kanpur. So let me take a problem by IIT Kanpur only. So there are two well-formed formulas. One is given as F1. What exactly is it? This is P implies not of P. The other being F2, which says P1 implies not of P, or not of P implies P. These two are expression. So these two are given to us. Okay, this was asked by IIT Kanpur in 2001. Okay, so we need to tell which one is satisfiable, unsatisfiable, valid, invalid, whatever. We need to just think about all of these. Okay, so let's just have a look at this. So this is first expression, this is second expression. You just tell me, just think about this. Very important. When we have this, if I say P is true, if this is true, then it is definitely going to be false. Then it is definitely going to be false. See, if P is true, then not of P will be false. For implication, just remember, when does this implication gets wrong? When does this implication gets a false value? Only when this is true and this is false. Only then our implication gets false. So over here we are having this directly. If this is true, this is false, it will be false. This will be false. What about the scenario if I say that P is false? If this is false, it doesn't actually matter what is the value of this one. It doesn't really matter. Though I know if P is false, then it is going to be true. I know that, but we have already learned from the truth table of implication that whenever the input P in P implies Q is false, the implication will always result in true. So that means it can be false as well as it can be true. It can be false as well as it can be true. So it is not always false, it is not always true. So in that case, what do we say? There are multiple statements which we can use. It's a contingency. We have already learned that. Or we can simply say this is satisfiable. This is satisfiable. Okay, the first part is satisfiable. Okay, this part is clearer. The F1 part is clear to us. Okay, what about the next part? We have this over here. What is it? Say this. P implies not P, or not P implies P. So if I just look at this carefully, what is it? P. So let's say this is true. True implies not of P. That means if P was true, what will be this? False. Or what is this? This is going to be P was true. So not of true will be false. So false implies true. So what will be the final output for this? True implies false is always false. We know that because that is the only case when implication gets false. Or false implies true. So whenever the P part is false, it is always true. That means it is going to be true. What is the output? It is going to be true. So this was true. If I say P is false, let's say this one. So let's understand. False implies this will be true, or negation of false is true. True implies false. So see this. From this I'll get true. This is or. From this I will get false. So again, what will be the value of this? This will also be again true. So depending upon, just take any value of P. Take any value, be it true or false. This will always result in true value. That means always true. That means it's a tautology. That means it is a tautology. I hope this is clear to everyone, whosoever are watching right now. Okay, so this is a tautology. I hope this is clear. Okay, so let's see. This is the tautology. We have learned that over here. Okay, now after this, what exactly we have got? F1. What is F1? F1 was satisfiable or contingency. F1 is satisfiable, or simply you can say contingency. And F2 is valid or tautology. F2 is valid or tautology. I hope this is clear. I hope this stuff is clear. Okay, so let's move further. Let's talk about the next question. Okay, Let's take next question, what we are having. A very good question we are having. Amazing question, literally. If X then Y, unless Z. This question was being asked by ISC Bangalore in 2002. By IISC Bangalore. What? If X, then Y, unless Z. Unless Z. Okay. This is being given to us. Okay. And then it is being asked which of the following formula in propositional logic represents this one. Okay. So see, this is important. We need to create a propositional formula for this. This is in basic English it is written. Okay. If X then Y unless Z. So how do I write this? Very important to understand. I can convert into three similar expressions. First of all, let me write, and then we'll write the propositional part. Okay. So if I write if X then Y unless Z, so I guess you might not be having any issue if I write it like this. If X then Y unless Z, that means if X, then I can take this in bracket. That means if X, then whatever that may happen. That means Y unless Z. Or what can be done? If X then Y. If X then Y. Now for this I will write unless Z. Or what can be the other scenario? Understand this, that for this condition to take place, understand this is very important, that for this condition to take place, which condition? For this particular condition to take place, this one, this Y is the situation. If X then Y, if X will satisfy, then Y will happen unless Z. That means till Z is not there, Y will be able to happen. Y will be able to give its output, whatever is there. So that means there are two conditions related to Y. One is X, the other is not of Z, because with unless, if you remember, we relate not of Z. So with Y to take place, there are two conditions which are important, X and Z. So both the conditions are important at a time. That means I can write this as like this as well. If X and not of Z, then Y. I can also write it like this, because Y is the situation which is dependent upon two conditions, X and Z. On both it is dependent, and for both the cases not of Z is there, not of Z. If X not Z, then Y. I hope this is clear. Properly. There must be no issue over here. Okay, so there must be no issue. I hope this is clear. So for all of these I can convert the corresponding, I can write the corresponding what? I can write corresponding expression for these. What will be the expression for this particular one? If X then Y unless Z. So that will be X implies, what do I write for this one? What do I write for this? Y unless Z. That means not of Z implies Y. Not of Z implies Y. What do I write for this one? The second word. Okay, that is X implies Y, and this complete part is being implied by not of Z. This complete part is implied by not of Z. Again, important point. Okay, now for this, if I see this is X and not of Z implies your Y. I hope this must be clear. So these are the three equivalent expressions for the same stuff we are having. Okay, these are the three equivalent expressions for the same stuff. I hope this must be clear. Okay, so in the options there were number of expressions which were being written, and let me just tell which one of these was. Let me just write all of these expressions. So what were the options which were written? The options which were written were these. A was x and z, negation of z implies y. B was x and y implies y not, basically y and z, something like this. C was written like x implies y and not of z, and D was x imply y and negation of z. So I hope that is clear already, that which expression is correct. It was this one which was written. So I have given you three expressions, not the single one. I have given you three expressions for the same stuff which was being asked in the question. Okay, so I hope this is clear what was the correct answer. Okay, so we'll do the next question. First of all, let's just drink water. Okay, so let's see. Now, if I talk about the next question, let's take the next question we are having. Okay, let's talk about the next question, what we have. Another good question we would like to take. Okay. So this is a very interesting question over here. We are given a table. With something like this. Okay. A, and this was asked by IIT Kharagpur in 2006. 2006 IIT question. Okay. 2006 IIT question it is. So we are given a table A, B, and some operation is given, represented like this. Okay, this is some kind of expression which is given to us. Okay, now what is the truth table given to me? Truth table is this is true, false, and false. This is true, this is false, this is true, this is false, and with this input, with these set of inputs, I have this as true, this is true, this is false, and this is true. We have this. Okay, so this is being asked to me that for whatever symbol this is, I do not know, I want to know which of one of the following is equivalent to A and B. Which one of the following is equivalent to A and B? Okay, and the options given are these. Negation of A, this operation B, sorry, this bracket is out. B part is negation of A and negation of B, like this. C part is negation of A, negation of B, and D is negation of A dot B, something like this. So all these are written to me, all these are given to me. So what is being given in the question? This is the truth table given to me, and I am being told that what is the equivalent expression for this particular one in terms of this operation, where negation is this negation, not, that's it, nothing else. These are same, negation. Okay, so this is being told, and it is being asked what is the equivalent expression for this in terms of this particular operator. Okay, so what do I get? So look at this truth table very carefully. And keep liking and sharing if you're getting something. Okay, see this, very important. So what is this truth table looks like? What does this truth table looks like? So there is only one false value, very important. It's important to understand there is only one false value. There is only one false value. And if you just focus on this, you, I hope, remember that in implication also we have a single false value in our truth table. And what is the false value? Like, when do we have this false value? When B is true and A is false. When B is true and A is false. So if you just try to relate with the implication, you will be able to realize that when do I have, this thing false? When do I have this expression as the false value? Only when P is true and Q is false. Only in that case, this expression result in false value. So I'm having this stuff and I'm having a false value, and B is true, A is false. That means A not A, this operation is nothing but it is equivalent to writing B implies A. This is same. This is same. This is exactly equivalent to B implies A. Okay. If we have got that, it won't take much long to find out the value of A and B. So just understand, how do we write, the simpler form of this? That means I don't want to use implication. I want to use the basic logical connectives. That means and, or, negation. So what is the expression for that? That is negation of B or A. Negation of B or A. Clear? Clear. So if I want to create negation from this one, if I want to create negation from this one, sorry, not negation. If I want to create from this expression, I want to create this expression from this one. How can I do this? How can I do this? It is very simple. We just need to be logical enough over here. If I put negation twice over here, negation over here, and I do this, what will be happening? Just have a look at it. If I do negation over here and put a negation over here, what will be happening? It will be converted into, De Morgan's law. B and A. B and A will get created. B and A will be there. Okay, B and A will be there. So that means I just need to put negation from this complete expression, for this complete expression, and take the negation of A as well. That means not over here and not over here. That means not over here and not over here. That means this is the correct answer. T is your correct answer. I hope this is clear how we have found it. I hope this is clear how we have found this. It's a good question to understand. I hope this is clear. Okay. So let's move to the next question. Let's move to the next question what we are having. Okay. Let's talk about this. Let's talk about the next question what we are having. Okay, this one again, a similar kind of question. I'm asking. Okay, this is given. Sorry, the question was asked by IT Kanpur in 2015. The question was asked. Sorry guys, the question was being asked by IT Kanpur in 2015. What's that? The question says there are two statements. S1 statement is there. There is one S1 statement which says if a candidate is known to be corrupt, if a candidate is known to be corrupt, then he will not be elected. Then he won't be elected. he will not be elected. Okay, then he will not be elected. Then another statement is also written, statement 2, which says if a candidate is kind, if candidate is kind, then he will be elected. Then he will be elected. He will be elected. On the basis of that, there were some conclusions written. There were some conclusions which were written. Okay, and we need to tell what exactly of these will match. What exactly of these will match. Okay, which of the following statements follows from S1 and S2 as per sound inference rules of logic. Okay, so let's see what are those statements written. Let me just tell you that. What are those statements? So there are options for that. Okay, there are different options written. So this question was asked in 2015 by IIT Kanpur only. By IIT Kanpur only. Okay, let's see. Let's see. If a person is known to be corrupt, the A option tells me if a person is known to be corrupt, known to be corrupt, then he will not be elected. Then he will not be elected. Okay, the other question, other option is, other option, person is not known. If, let me just repeat this. Let me just repeat these. I'll repeat the part which I'm require. If a person is not known to be corrupt, he is not kind. He is not kind. He is not kind. This is the second option I'm having. The third one is C part. Third one. Third one. Okay, third one. C part. C part is if a person is kind. If a person is kind, he is not known to be corrupt. He is not known to be corrupt. Then he is not known to be corrupt. He is not known to be corrupt. Okay, and the last option is if a person is not kind, if a person is not kind, person is not kind, what do we replace? If a person is not kind, then he is not known to be corrupt. Okay, so these are the options I'm having. And these are the important, statements given to me. So I need to just tell which of the ABCD options are correct. Okay, whether I can draw the conclusion or inference from these two, that which one of these are correct or not. So let's see. So let me write for this very in a simple way. Candidate is known to be corrupt. That means if a candidate is known to be corrupt, CC, I'll write CC for that. Candidate is corrupt, then it will imply he will not be elected. He will not be elected. Okay, and I will write its contrapositive as well, because that may be utilized somewhere, because you know contrapositive of an implication is always same. That means if someone is elected, then it means that person is not known to be corrupt, that candidate is not known to be corrupt. What is the second statement I'm having? If a candidate is kind, he will be elected. If a candidate is kind, that means he will be elected. That means what will be its contrapositive? That means if a candidate is not elected, that means he is not a kind candidate. The candidate is not kind. Okay. So from these, let me just draw some conclusion. If a person is known to be corrupt, then he will not be elected. What? Corrupt, not elected. If a person is known to be corrupt, he will not be elected. Candidate is known to be corrupt, then he will. Okay. This is something I have written like the first part only. This is not the first option. If a person is known to be corrupt, he is kind. Okay. Sorry. He is kind. He is kind. Okay. What is the next part? He is not kind. Okay, now is fine. So let's see. If a person is known to be corrupt, that means CC implies K. Is it so that CC implies CK? Is it so? The answer is no. The answer is no. CC implies not E, and not E implies not CK. That means if a candidate is known to be corrupt, then he is not kind. He is not kind. So this is false. This is not true. What about this? If a candidate is not known to be corrupt, if a candidate is not known to be corrupt, if a person is not known to be corrupt, he is not kind. Okay, let's see. That means not CK implies not CC implies not CK. Not CC, so I cannot say anything about this. Not CC does not imply anything over here in our statements. So I cannot say anything over here. So this I cannot say anything. What about this? If a person is kind, then he is not known to be corrupt. What does this mean? It wants to say that CK will implies not CC. Can I say this? CK implies elected. That means if a candidate is kind, that means he is elected. And if someone is elected, that means for sure he is not a corrupt candidate. He is known to be not a corrupt candidate. That means it is correct. Candidate is kind. If a candidate is kind, then he is not known to be corrupt. That is correct. Okay. Similarly, when we'll find it out, D will also be wrong over here. D will also be wrong over here. Only C part will be correct. Okay. I hope this is clear. So let's take the last question for the day. Okay. More we'll discuss in the next sessions. That will be in the recorded forms. Okay. The next few sessions will be in the recorded form only. So let's talk about this. Okay, so there are two questions I would like to discuss, and then we'll end this session. The first question is this. Let PQRS be the propositions. P says, this is the question. P says X belongs to this category. This set 8, 9, 10, 11 and 12. Q tells me that X is a composite number. What? X is a composite number. It is being told by Q proposition. Okay. Composite number. Okay, this is clear. R says X is a perfect square. X is a perfect square. This is clear. S tells me X is a prime number. X is a prime number. And then expression is given, and we need to find what is the value of X. Then expression is given which satisfies this equation. There is some value of X which satisfies this propositional expression, which is not of P implies Q and not of R or not of S. There is some value of X which satisfies this equation, this expression, and we need to find that. So let's see. Very simple question, not very difficult. Okay, not of R or not of S. Okay, not of R, not of S. So if I take this just not common over here, what do I get? Just let's see this. P implies Q as it is. Okay. And not of, what is this? This is nothing but R and S. R and S. Okay. So I hope you know this, that R and S. R and S. Where is it? Yes, R and S. This. So there is no such number which is a prime number as well as a perfect square, because for a perfect square number there will always be a divisor which will be its root. For a perfect square, its root will always be its divisor. So any perfect square which any perfect square number cannot be a prime number. Any prime number cannot be a perfect square. So from this is empty, this is empty, we do not have anything over here, this is empty. Okay, so because this is empty, this is false, negation of false is true. So yeah, ultimately what do we get? We get this only. That means negation of P and then this Q. Okay, what does P and this thing means? This is nothing but negation of, I can write it as P or Q. And if I solve it further, what will I get? I will get P and not of Q. P and not of Q. That means I am looking for a number which satisfies this condition and do not satisfy this condition. If a number does not satisfy this condition, what does it mean? That means X is a prime number. X is a prime number. And if it belongs to this, that means the prime number must be one of these. So which one of the prime number is present over here? Which one of these is a prime number? The answer is only one, that is 11. 11 is your correct answer. 11 is your final answer, because 11 is a prime number as well as it belongs to the given set. It belongs to the given set over here. Okay, so I hope this question is clear. Very interesting. Okay, very interesting. So now let's move on to the next question what we are having over here. Now let's move on to the next question. I hope this is clear to everyone, each one of you guys. Further lectures you will be getting will be in the form of recorded videos only, because most of the people, I guess, are not interested in chatting and coming live in the live sessions. So it's okay, we'll be recording and then uploading the videos. And if you have any issue, you can just let me know. Okay, you can just comment in any of my uploaded videos. Okay, so let's take the last question of the day. P denotes, this is a question which was being asked by IIT only, IIT Roorkee. Okay, so P denotes it is raining. It is raining. Q means it is pleasant. It is pleasant. R means it is raining, it is cold, it is pleasant. Okay, I have changed the order. This has to be it has to be written below. Okay, it is cold. Over here I need to write it is cold. Over here I need to write it is cold. It is raining, it is cold, it is pleasant. And then I need to write an expression for this particular one, which is this: it is not raining. It is not raining. It is not raining. And it is pleasant. And it is not pleasant, only if it is raining and cold. It is raining and it is cold. And it is cold. So let's see which expression will be like created by this one. So this is the complete sentence given to me, and I need to convert this into the I need to convert this into the expression, propositional expression. It is not raining and it is pleasant. So I guess you know this. Very simple for this one. It is not raining and it is pleasant. That means for not raining, it is not of P. What is this? And it is pleasant. That means R. Okay, this is clear. Okay, this is clear. And it is and what? And it is not pleasant. It is not pleasant only if this is the stuff. Okay, so for this you need to understand whenever I had this kind of situation. Okay, what P only if Q. So I hope you remember P only if Q means P implies Q. So what do I have after this? And it is not pleasant only if. That means not pleasant. Not pleasant is not R. Not R implies what? Only if it is raining and it is cold. It is raining and it is cold. It is raining and it is cold. That's it. That's it. So this is the exact propositional function. Sorry, it is the exact propositional expression corresponding to the statement which was given to us. It is the exact propositional expression for the statement which was given to us in English. Okay, so in this way we can convert any given statement to our propositional expressions. Okay, this must be clear. It's like a very easy point. It's very easy stuff. Okay, we just need to understand how does these things work out. Okay, so in this way we can solve a number of previous year problems, but there will be no advantage if no live audience will be there. If it is there must be a situation that there is a live interaction, proper interaction. Then only teacher enjoys, student enjoys. Otherwise it will be very monotonous and very dull. Okay, it won't be like very much enjoying section. Okay, so if you want an enjoyable session, I hope you must come in the live session. So next 3-4 session I'll be taking will be in the form of recorded videos only. Okay, I won't be coming live now for the next few videos, so that I hope you get understand and you may join me in the live session after some days. Okay, so till this point I have covered the propositions. So in the next session I will be again uploading a video in which I'll be solving some previous year problem only, nothing much. Okay, so in the next video which will be there uploaded, because there will be no session tomorrow, I'll be taking I'll be discussing some PYQs only. After that, some days, okay, I'll be talking about the first order logic and predicate, and we'll be solving some problems in the live session. I hope you would be there in the live session, and that would be more interactive one, like unlike these sessions which these are going on. And I hope if anyone is watching, you must join live. That would be very much advantageous, because that doesn't create any issue, and that won't be like, it won't be monotonous much. Okay, so I expect you guys to be there in the next session. Okay, so see you guys in the next session whenever we have this in the live way. Okay, in the live form. Till then, keep enjoying the recorded lectures. We'll meet you guys soon. Till then, bye bye, take care, thank you.